This podcast is brought to you by ngrok. If data is the lifeblood of a modern IT organization, ngrok is the circulatory system moving that data from where it is to where it needs to be with a seamless, easy-to-use SaaS offering. Maybe you're trying to standardize the application delivery policies for your organization across multiple data centers or cloud environments. Or you're building a SaaS offering that needs to deploy and manage software inside customers' networks that you don't control. Or you need to be able to connect to IoT devices regardless of which network those devices live on. ngrok allows you to access that data in a way that is both developer and CISO friendly. For more information, contact ngrok today. And now, on to our show.
Can I get the icon in cornflower blue?
Hey everybody, welcome to episode 32 of Can I Get That Software in Blue? I'm one of your hosts, Chad Tyndall. Along with me is my co-host, back from a recent trip to Vegas where he saw the giant eye so high up in the sky that it was hard to believe. Steve, my love for little Dicky will never lack. Mazak.
Bringing some good, interpersonal stuff in there. I like it.
I know. I think you also want to be Mr. McAdams, don't you?
I mean, I do like Rachel McAdams, for sure.
Such a great song. I don't know why that popped up in my head this morning, but I was listening to it, so
it is
I worked it in.
Yeah, I love Lil Dicky, that show that he does, Dave, on FX. It's so good.
I want to see that giant sphere. How is it in real life?
Yeah, it's amazing. It's as impressive as you think it is. Like, we came in from the Phoenix side, so through, Henderson and all that. It looked like a beach ball when we first got to the city, and it was daylight. So I made a point to my wife, Jennifer. I was like, hey, we need to go drive there at night. So we did on the last night we were there.
Like you drive back out?
Well, no, just drive up to the sphere. Because we were still pretty far away. It's over by the pirate one, Treasure Island, and it's connected to the Venetian. It's connected to the Venetian. There's plenty of places to drive. It's really packed because everybody's doing the same thing. But once you get up close, it's kind of weird because when you're not even that far away, it looks really good. It looks high definition almost. But when you get really close, there's almost a hand's width between each pixel. And that should kind of tell you how big that thing is. It's massive.
So when you're close, can you really tell what's actually being displayed on the screen, or is it looking really close at a TV?
You have to kind of look at an angle. It's kind of weird. Yeah. So when you're really close, it's a little harder to see, but you don't have to get that far away to see what's on it. And I can't wait to go inside because now that I've seen the outside, it's just massive, and I've seen the renderings of what it looks like on the inside. I think it's going to be a really great venue for stuff. And given that it's attached to the Venetian, I'm sure Amazon's probably going to use it for reInvent. Next thing you know, they're going to be doing product announcements in 360 degrees on the dome.
Yeah. Giant crypto ads.
Yeah. Look at the new Lambda function. It's 180 feet wide.
Oh my goodness. It's a weird attraction because, unlike the water fountains of the Bellagio, they're sort of designed to draw people in. Like you said, that one looks better when you're further away. And that's kind of interesting. But I would love to go to the opening, that U2 concert. There's 100,000 speakers inside because every chair has multiple speakers connected to it. So I bet it's going to sound incredible.
Yeah, I hope so. I can't wait to see a show in there. One of many, hopefully.
One of many. All right. Well, our guest today was the co-founder and CEO of Swiftype, a SaaS company that made it very easy to add a search bar to any web application without having to write any complex back-end indexing or search code. Swiftype was acquired by Elastic in 2017, and our guest is now the general manager of enterprise search at Elastic. He's an engaging speaker who never talks dryly, and even though is sometimes wily, we still think of him highly. Matt Riley, welcome to the show.
It's great to see you both.
Well, Matt, thanks for joining us on the show. I really appreciate it. It's good to see you. We worked together at Elastic, for those that don't know, for years and years. I was part of the due diligence team at Elastic that, got to go into Swiftype a little early and learn. And I'd never done due diligence on an acquisition before, so it was just a really good learning experience for me. Matt, I want to talk to you about Swiftype first, and then we'll kind of go into Elastic, and I eventually want to get to talking about your guys' AI vision and how you're thinking about that and all that stuff. So let's start back with Swiftype. When you started Swiftype, you were an engineer. I think you'd worked at a few other companies before that. Why start a search company at the time that you did? Because looking back at that time, it doesn't seem like a great time for search. It's not a bad time. It's just why that time in particular?
Yeah, it was an interesting time for sure. And I think what really propelled us to do it is kind of the thing that is at least one of the classic reasons to do a startup is just something that I had worked on with my co-founder, Quinn, who who came to Elastic as well. He and I were working together at a software company before that, and we worked on a really big search engine implementation. It was high scale, lots of content, lots of data, constantly being updated, and we built this product it was basically a feature of our product. We built it over the course of maybe 9 months or something, and it felt like it was extremely difficult to do. And it was. We researched a lot of the products in the market. We tried 3 or 4 different approaches over that period of time, and nothing really worked all that well. So we ultimately ended up building something that we thought it worked quite well, but it took a lot of time and a lot of energy, and it wasn't even really our core job, right? We had other, features that the whole point of the software that we were working on wasn't just the search functionality. We sort of thought, this was a time when SaaS products were really taking off. This was like 2011 or so. So we were thinking, hey, this could be a good opportunity to turn this into a SaaS. At the point in time, there weren't really SaaS offerings for search as a service, but there were a couple of different open source products. Elasticsearch was just now being released in its earliest version. So it hadn't been established yet. So we didn't spend that year working with Elasticsearch, but when we started Swiftype, we actually chose to build the core search functionality on a really, really early version of Elasticsearch, sort of not exactly on a whim. We did a lot of research into what we wanted to do to build that infrastructure, but it was pretty clear, even in the very earliest versions of Elasticsearch, just how powerful of a piece of software it could be, and just how elegantly designed it was. That's why we ended up basing it on that architecture, and I think we're very happy with how that all played out.
Right on. So the company that you built that search engine for, that was ScribD, right?
That's right.
Like you said, 2011, you started Swiftype in 2012. What was that like to kind of make the decision to leave what I assume would be a stable job and go out and just try and, carve your own path in the world?
Well, I think that, luckily for us, Quinn and I were both quite young at the time. So we didn't have a whole lot of anything else going on other than work. And so we didn't have a whole lot of risk to mitigate when it came to doing this. I think actually the hardest part was we really liked the job. We both joined Scribd at a time when it was an early stage company as well. It was one of the first, it was a kind of one of the early companies in that wave of Web 2.0 startups that started around 2007, 2008. So, and we were early there. At the time, it was one of the most highly trafficked websites on the internet. So we were like a top 10 website in terms of traffic, which is also why our search capability ended up being such a high scale implementation. And so we got to learn a lot. We liked the founders a lot. We worked really closely with them. So I think the hardest part actually was just leaving a group of people who we felt close to and who had, we had built a lot with. But then the urge, and I think probably the reason he and I both originally joined Scribd was because we were interested in being entrepreneurs ourselves, and we had a lot of startup ideas. And he and I ultimately ended up having come across a few different ideas over the period of time we were working together. But when we finally realized how hard this search thing was and that we could probably do it better, that was when it became really obvious and that we should go for it. And so we applied to Y Combinator. We went through the incubator program, and I think that was good motivation for us to really go and take it very seriously and really start to embark on the process of learning how to actually build a company, which is very different from just, grabbing an idea and working on it for a couple of months with your buddy in an apartment. The process that's just the very beginning, and it takes a lot after that point, but we had a great run at it.
Yeah, and it's been over a decade now since you started Swiftype and joined Elastic. Like, if you could go back and tell young Matt and young Quinn, these are the 3 things you need to remember as you go forward, like, what would you say?
That's a hard question, actually. I've had a lot of time to think about it, and I might give answers that you might not expect. But one thing that I think we learned very quickly. So obviously, like you mentioned, Quinn and I are both software engineers by trade. So we started the company because we build software together. And I think it is important, even early in a company, to really figure out your go-to-market strategy and think about that. And so with 2 software and very product-focused founders, your inclination is to think that you can solve all problems with more product or better product. And so we did that for a while. And I think it took us maybe longer than we wanted to realize that the other half of the company is also incredibly important to build in the same way that you build your product and engineering team. And so once we really started to focus energy on that, that's what the company really started to grow. We started to build revenue and things like that. But that stuff doesn't just happen because you have a really well-built product. You have to really put a lot of energy into doing that. We learned that probably slower than I would have liked. I also learned a lot about just operating efficiency inside of a company and how important that can be. If you can really think about your operations and the way that you run the company and the way that you do things like finance and planning and reporting and getting that as clean as possible early on, it's really hard to do that once the company's really going, right? Once you have a lot of customers and once you have a lot of things going on, layering on operational excellence is much harder later. And we tried to do that obviously as much as we could. But I think if we were to go back, or if I were to go back and do this again, I think that would be one of my bigger focal points in the early days, is to just get that stuff as well planned out as I could when it's still easy, because then you're building on a kind of a better foundation. And every company I know, and my friends who run startups, I think everybody struggles with this because it's just not the thing you think about when all you're doing is trying to get your product built and get your first customers, and you're emailing people and you're talking to every customer who signs up. And so you're just doing anything and everything to get it going. That wasn't my focus, but that's one of the things when I look back that I wish I'd known to just spend more time on. It's not necessarily that complicated. It's just a area to put your energy, I guess.
A catch-22 as well, because you could argue that if you spend your time there and not on other things that are going to make the company successful, then it doesn't matter, right? And I think that's one of those psychology things you have to constantly battle is, am I doing this for a future that may never come? And should I be spending my time somewhere else, right?
Yeah. I totally get it. I think that is hard. And then that's the question. And I think hopefully you're lucky and you get a good co-founder who you can have a good relationship with. But I think co-founder relationships are oftentimes hard. And when I talk to my friends who have startups, or whether they've worked or not, I think, every startup has a lot of back and forth between the founders. It's a relationship that's hard to maintain. So I think we did well. So I don't know that I would do that very differently, but I think that just making sure you're focused on those are all the important bits for me.
Well, it's interesting. Like you and Quinn were friends before this. Is that right?
Mm-hmm.
And before Scribd, did you know each other before Scribd, or is that where you met?
That's where we met. Yeah.
Okay. So, I've heard a lot of people say you should never go into business with friends or family. Why do you think it worked? Assuming you think it worked, I think it worked.
Yeah, I think it worked fine. Yeah, I don't know that I would. I think it depends, right? I think that you have to, whether you're friends or family or not really great acquaintances, I guess, it's more like an alignment of what you want out of the business. And as long as you feel fairly aligned and you can communicate openly to each other, I think you can make it work. I think the hard part about family is that, if you start with family, it's like, who knows what kind of things you're bringing to that relationship that's now part of your company or whatever. But, it's also true that once you start a company with someone, you're kind of in that very close relationship anyways. You can't really get rid of each other. It's like you're stuck in the company together. And certainly you can, leave your co-founders or boot someone out, but it's a process and it's really hard for the company. So it definitely, I think just in some sense, maybe I'm just saying it's good to be lucky and find someone who you are aligned with and has similar goals and ideas about how to do all the things that you don't know you're necessarily going to even have to face in running a company, which certainly we didn't know. We learned it all along the way.
You guys start Swiftype, you're off and running. Like, what was it like to get those first few customers?
We spent probably 4 or 5 months just building infrastructure from the ground up. So when we first got into into Y Combinator, we, typically the advice is launch as early as you possibly can. We kind of had to build a lot just to get to a place where we could host real customers. And then, so we actually launched after Y Combinator was finished. We raised a little seed round at the end of Y Combinator, but we didn't have the product in production. And then we launched maybe a couple months after the program ended. The first few customers actually came off of a TechCrunch article. We had an article written up in TechCrunch when we did launch. And I remember seeing them all roll in. We emailed and talked to every single one of them and asked them about what was working and what wasn't. We got to know a lot of people who we actually, ended up being fairly close with. Actually, some of the people who you also know who ended up coming to Elastic with us, some of them were early customers of the company. Jonas, who is our head of product there, he actually was probably one of the first customers of the company because he was working at Shopify at the time we launched the product, and he was looking for a search system for the documentation on Shopify's website. And so he came to us and he was chatting with the support team on our website through the little chat bot. And that support team was me and Quinn. So we were answering all the questions, and we ended up getting to know this person who was running this thing over at Shopify. And he ultimately ended up moving to San Francisco and came to work for us at some point. So those first few customers, I guess to get to your point, you just kind of try to get to know anything and everything about them. I think that one thing that we share with things I've heard from Shai from the early days of Elastic, where you were probably part of this too, we just went above and beyond, like well above and beyond for the earliest customers to just make sure that they were successful in what they were doing. Because we knew that getting people successful with the product taught us a lot about what it needed to be. And certainly we didn't have so many customers that we were just inundated that we couldn't spend the time. So we did that. And I think that ultimately that was the right way for us to build the business. And we ran support for, just the two of us probably ran support for 2 years and read every single customer support email that came through. I think when we were acquired, Quinn still read every single customer support email. I mean, honestly, at one point in time, I think that was one of our founder arguments. I was like, you need to stop. You can't read every support email where you're going to drive yourself totally nuts. But, it's a habit, and you learn so much through that channel. I think I still encourage product managers when they join the company to read all of our support channel that comes through at Elastic. And certainly we did at Swiftype. That was your first couple of weeks of onboarding. It's the best way to learn about what's going on.
That's right. It's kind of like being a detective too, because you kind of think, okay, how do they get into this situation that they're in? Because they're not going to tell you the whole history and like what they're trying to accomplish all the time. It can sometimes be like, this isn't working, fix it.
Yeah, and they're always using it in a different way than you imagine that they would use it, right? Like, why are you using it that way?
Totally true. And you also have to eventually learn, and it took some time to learn that usually they're asking a different question than the real question, or that happens often enough that you have to kind of figure out like why they're asking the question they're asking. And then you can sometimes figure out that there's a very different thing that you need to help them fix. And diagnosing that is a really hard part of customer support, actually. I think it's one of the things, it's the true skill of the really great customer support people is figuring out like the question inside the question. And it's certainly something that's not all that natural, especially if it's a product that you built and you're just like, well, just, read it. It's in the docs, right? But it's like there's more to that, right? And that was, I think, what we learned by just trying to go above and beyond, at least in the earliest days.
I think that's a great point. Like, this might not work. This analogy might not work, but we'll see. I can't have ancho chili, and I went to this Mexican restaurant the other night, and you can imagine how this is like a minefield for me. Hey, I can't have ancho chili. I only had to say it twice, and the rest of the night, everything that we ordered, like the whole meal was taken care of. Any ancho stuff was brought on the side for other people and not put on anything. And I was like, this is the question behind the question. I just said, hey, does this have ancho chili in it? And they asked me, they're like, why are you asking that? Probably you have an allergy. But then like to go and take the next step, I felt like that was good product management at a restaurant, if that makes sense.
They were owning the customer outcome.
And they all owned it together too. Like I only had to tell one person twice, and then everybody, there's probably 3 people that were coming around the table. They all knew. So
the problem that I see with support stuff that comes up from time to time is that they know what they're trying to do, but maybe sometimes their mental model of how all the things fit together isn't right. And so you actually have to figure out, okay, they're having this problem because their mental model of something is broken. And then you have to fix their mental model, and then you can fix the problem.
It's not necessarily broken, Chad. It's just like they don't have the full picture, right?
Whatever. They're not in it as deep as we are. So we write software, we make assumptions because we're deep in it. We don't always think about, what the customer or the user might not know coming into it.
Well, that's why I think API design is so important and so hard is because you're basically trying to wrap all the complexity of what you just built into a language that other people can understand without having to do the deep dive that you did to build it. That's the hard part about an API.
Some of the most interesting abstractions that we built in our API, something that we're still proud of today, are things that came out of consistent misunderstandings from the customer's perspective, where these things it may have been just like dead simple in our heads, but they were the things that everyone seemed to get confused by. And it forced us to go back and think like there must be a better abstraction here. And a couple of those things that we invented are things that are still part of our like key parts of our product today that just work kind of magically for people that no one knows about.
Can you give us an idea of what that is, Matt? Like,
What's an example?
I can give you one. Given your background in Elasticsearch, you'll probably understand this, but it's a little bit esoteric. There's a difference between like strings that you push into the search engine that are tokenized that you use for matching text, and then like from a keyboard input, and then the types of strings that you use for like creating filters and facets, like a category or something.
Yeah, like n-grams versus everything else kind of thing.
Exactly. And so we had what we called like an enumerated value, which is like a keyword value in Elasticsearch. Those don't get broken up. They're just the string, right? And then we had a text field, which is like text that gets broken up and then used for matching strings and doing phrase matching and things like that. We had two different field types for those. And we realized that no one really understood the difference from the outside. They were kind of like, oh, well, why would I choose one for the other? It's all text, right? They're all words. And this caused all these problems. And so we ended up just storing everything as both. And when someone used every text field, we just store it as both the text field as an enumerated value or as a keyword. And then anytime someone used it as a filter under the hood, we just made sure that we referenced the keyword version of it. And if they used it for search, we referenced the text version of it. But all of that stuff was on our side, at least inside the software, and we never had a problem with it again. But it's one of those things that no matter what we did in the documentation to explain why you would use one over the other, it's just not the sort of thing that people are thinking about when they're just thinking about building a search engine. This actually came up in Elasticsearch too. It wasn't in an early version of Elasticsearch, but eventually Elasticsearch built an abstraction over this as well, because I think that the team at the time, it was before we had joined, I think they realized that their customers were also finding similar challenges. So it was actually fascinating to see that happen, especially once we were on the inside. We're like, yeah, no, we know that problem, right? So it's stuff like that.
That's a good example. Like, and you're right, it's esoteric, it's pretty deep in the product. And once you understand it, it's a little bit demystified, but it's still not, because like at the end of the day, I just want to be able to do search and filtering at the same time. And why can't I do that? Matt, let's talk about the acquisition, and then I want to focus on, fast forward to today. So when you guys first got approached by Elastic, was it like the first time you had thought about maybe selling the company, or how did that all happen? How did that all go down?
We had engaged in acquisition conversations probably from pretty early in the company's life cycle, possibly because search was a technically hard problem. And so we were, building this software team around it. And so a lot of companies were interested in it. So it wasn't the first acquisition conversation we had ever had. I mean, we had gone relatively far along in the past, but never found one where we felt like it was really the right thing for us or the outcome that we were looking for. And then when we met Shai, through this process, a couple of things clicked. One, just the fact that Shai is Shai. We really enjoyed spending time with him, and he was someone who we felt, we had common ground with, but also the interest in where our product was and where it was fitting into what Elastic was trying to do. The introduction of solutions on top of Elasticsearch, and we were going to be able to bring our product along. We brought our customers with us. We brought, the team with us. I think it was just a really good fit for us. And we were actually at that point in time talking to a couple of other potential acquirers, because we had just released the enterprise search product at the time that I think stirred up a decent amount of interest in us as a business. But, we had meeting Shai was very different from the typical kind of like corp dev acquisition process that we had been accustomed to. And, it fit together, I think, really nicely.
You mentioned that you added like this new product line, this enterprise search thing, is sort of a second line of business to, building a search bar into an application. Was that something that you guys had always wanted to do, or was that something that you guys decided to do as a result of Google killing their search appliance, or how did that come about?
There were a lot of things that went together. Google did kill the search appliance, and we knew that that was happening. So that had some impact on it. But also, it was a time when, like I said, in 2011 or so, when we started thinking about this, was really when, certainly that's not when SaaS was invented, but that's when there was just like this explosion of SaaS tools out there on the market, and they were getting really good. And as they got really good and it became more competitive, they all became more and more sort of like focused and point solutions on different aspects of like running a business. So, where a company may have originally had 5-6 pieces of software that ran most of their business, now companies were using 50 different SaaS tools. And so the information inside your company started getting more and more distributed across all these different tools. This was also at a point where most of these companies had APIs, and most of those companies had standardized around OAuth for authenticating into their products. And so it was kind of a nice combination of there becoming more of a need to pull data together from enterprise productivity tools, the kind of these digital native tools that people were using to run their companies, and also an opportunity where the technology had come to a place where we weren't necessarily going to have to immediately start going in and putting like software agents inside of your company to crawl your internal network drives. It was actually more like we could just let the company grant our servers access to their Zendesk account via OAuth, where we wouldn't even have their authentication credentials, but we could access on their behalf, which they could revoke at any time. But then we can go inside of Zendesk and start pulling the data out, and then do the same thing for their Google Drive and start pulling all of that information together. So we saw this kind of interesting opportunity of the technology coming together and the need coming together, and certainly some market forces like the Google search appliance going away, and having a bunch of search infrastructure already built and knowing a lot about building that at scale, because at the time the company was fairly mature already. We thought that we could build a really interesting and compelling product. And so we built that enterprise search product over the course of a few months, the company. I think we probably underestimated how difficult it is to add a second product line to an existing company when your customers are used to seeing one thing and one thing only, and then you suddenly give them an option. There was a lot of confusion. All right, like, am I supposed to be using the enterprise search thing, or am I supposed to be using the site search thing? And is the enterprise search thing just like the really good version of the site search thing, or is it actually a separate product? We had to figure all that stuff out, which was an interesting lesson in product marketing and all of the things that come along with that. But we did figure out a lot of that. And I think we built a really great product, actually. It's one of the things I'm most proud of at the company. I think Swiftype's original site search product was innovative in a unique way, and I think that we were one of the first of what is now, a kind of a larger industry, and one that we're seeing more and more entrants into. But we were one of the first of these sort of like more modern types of enterprise search, or what we call workplace search products now. The products for employees to use to do their work faster and organize the internal knowledge of the company. And I think there's an enormous amount of opportunity there.
Absolutely. And I'm sure we'll get more into that opportunity when we start talking about generative AI, right? Which I'm sure for companies will be based on training from all of their internal data, which you're able to scrape with your enterprise search tool. So I don't even know if you were thinking about it in those terms, when you created it, but it was almost prescient that people would want to do this now with generative AI. They need access to the whole corpus of their enterprise data to do that.
Yeah, I think that Gen AI is definitely, it's breathing life into an opportunity that has always been there, but in a even more meaningful way, to the point where I think that it's possible now that this becomes, we can talk about all the things that are also challenging about the enterprise search space or the workplace search space. But I think that with generative AI, there's an opportunity where it really does become like an indispensable tool for every employee inside the company. And that's a hard thing to create, right? You have to have something really compelling, like the ability to answer deep questions and provide prescriptive answers, like what we're seeing with things like GPT-3 and 4 and some of the other foundation models now. And how you plug that into your private data is a complicated thing. It's something that we work on at Elastic, and so I think it's a very exciting area.
Today, if I wanted to add search to my site and it wasn't already there, About how many clicks do you think I have to go through now in the tool to do that as a layman?
As a layman, still today, you can do it pretty quickly with the site search product. It was, as you know, it was based on using a web crawler to index all the content, which is the fastest way. And your many years of experience at Elastic, that, the biggest challenge initially is just getting the data into the system, right? Because it lives somewhere else typically. So we shortcut all that by building a web crawler. And we could just say, hey, give us your URL and we'll go crawl your website. And then once the indexing is done, or once the crawling is done, which you can do fairly quickly, the process from that point on, we had a little JavaScript embed that you could copy and paste, kind of like a Google Analytics code snippet that you would put into the bottom of your web page. And it would draw the search bar for you. It would do all the JavaScript communication back and forth to our API and display results on your page. So you could probably still do it in a few minutes, probably less than 20 clicks. It's pretty streamlined. And then I think the trick is in figuring out how you allow people to customize beyond that, because that's kind of the out of the box sort of thing. And one of the other unique things, and I think the big challenges of search, is that no search box lives really in isolation. It's always integrated into some other thing. It's integrated into your website or your SaaS product or your mobile app or whatever else. So it has to be custom. Doesn't have to be, but almost always it needs to be customized and it has its own interactions. And so it's just not a one size fits all product. The output ends up being an output that goes into other software, which is why it's a developer tool ultimately in the end, even if it's been simplified.
Well, and ultimately, like after you get the search box up and running, that is step one in a 1,000-step journey of trying to tune relevance, right? And actually make it work for people. We were just talking about chat as maybe this interface, this new interface for a problem that's been there and it's been solvable in other ways. But do you think that's part of the reason that this new opportunity has come up is because we've unlocked a new way to interact with the technology through a conversational interface? And now it just allows us to expose all the functionality that we've had previously, but now in a new way to interact or a new way to engage.
I do agree with you that the new sort of the novel interaction models is compelling. And we've had chatbots in the past, though, right? Chatbots were all the rage like 4 or 5 years ago. They just didn't work. And that was the problem, right? They're more like the phone tree that you get when you call.
Yeah, if you've ever rage quit on United when he's like asking you what you want and you're like, I want to talk to a human.
Yeah, exactly. That was kind of like the Gen 1 of chatbots. But I do think that this sort of novel interaction model, and what I would say is probably novel about it is that now you can write a fully featured question in natural language and it will understand it. And that's really what's changed, is that you can ask a natural language question that it has nuance to it, can have a lot of context to it, and these foundation models can understand it and then provide this generative response that can be very detailed, which is certainly very new. That wasn't part of the way the original versions of chatbots worked. And so I do think that there's something very novel about being able to interact in true natural language. I think that chat interfaces in particular, where you are having a back and forth conversation, there's some limited utility just in that model because it is in some way a laborious way of asking a question or getting information out of it. And I oftentimes get the question of like, do you think it's going to replace, search on websites entirely? And I think my personal view is it's very much so additive to what exists today. And it will replace certain types of interaction that don't work well and never have worked well in the more keyword-based model. A lot of the kinds of things people search for on the internet, especially if you go to homedepot.com and search for something, half the time what you're really doing is you're navigating through the search box. You know that the thing exists. You're not searching for something. You're just trying to get there as fast as possible and typing a few letters and seeing the autocomplete drop down and then, selecting the thing that you wanted. That's the fastest way to get it rather than trying to figure out a menu navigation structure. And so like for navigational searches, they'll be around forever. And I don't think that those are going to be the kinds of things that get replaced by a big chat interface. But then if you're starting to ask questions like, about what the process of installing a tile backsplash in your kitchen looks like, that's probably something that you can ask a really nice generative AI system today, and it can give you a really good answer. I think I'm excited about the fact that it's additive. It augments what's possible and has been possible in the past. And it is a very new kind of interaction model. And we don't even talk about it that much, but I think that the possibilities of sort of doing this without an interface is also interesting. Like, I can't say the word because it'll wake up and start talking to us. But, the speakers in your office that you sometimes chat with, they're not as good at understanding natural language as you would like them to be. And that's a big opportunity now that these new models are better capable of understanding that. And so, you can imagine those things improving pretty dramatically over time once this technology gets baked into the kind of interfaceless, ubiquitous systems that kind of people have in their homes or potentially eventually in their offices as well.
Yeah, it's fascinating right now to think about all the possibilities, but also, like you said, some of the limitations. Ultimately, if you're going to provide a conversational interface for a technology, then your results now are only as good as your ability to communicate. And not everybody has the same capability. And there was that, I don't know how long the study was done over. There was a thing published a little while back that said, like, basically the smarter you are, the better results you get from ChatGPT. And it was kind of proving that point of like, if you ask better questions, you're going to get better results. Not everybody knows how to ask the question in the most detailed way, potentially.
I think it's where you start to really learn if your product management skills have paid off or not. Can you actually describe the question properly? That's always the complaint from the engineers. It's like, what the PM's asking for this, but what are they really asking for? Like, is this spec'd out? Is it described properly? If you can't get ChatGPT to answer your question, that's one way to get better at it, is to start trying to write product specs. And then you'll learn quickly. But I totally get it. I'm with you.
So recently you did a video, and it's on YouTube if anyone wants to watch it. Chad, we should link to it in the show notes. But you and Ash Kulkarni, the CEO of Elastic, did a video talking about your guys' new offering, ESRE. And I was wondering if you mind giving us and the listeners a little bit of a commercial, and then we can talk in detail about what ESRE is about, what the competitive landscape looks like, and what you guys are trying to achieve.
So what we call ESRE, or the Elastic Search Relevance Engine, was really the culmination of several different capabilities that we've been working on inside of the Elasticsearch stack and the overall ecosystem, but mostly kind of originally different capabilities that were building blocks, which is how we build most of our software. As you know, it's a developer tool. And so we start at the base functionality, and then we hopefully, if we're successful in doing our jobs right, we build them in a composable way that they can all work together well. And ESRE was really taking things like the introduction of a vector search database into Elasticsearch and the ability to bring transformer models into our machine learning capabilities and do inference inside of Elasticsearch, and a couple of other kind of related capabilities, pulling all of that together into one, cohesive release of software, because they all kind of came together at the same time. And the goal is to, it's not really too different from the goal has always been for Elastic. It's just that we realize now that there are new techniques for getting to that final output goal. The goal is really to help our customers build the best relevance capabilities for whatever data they need to search over. And we can get into why relevance remains kind of key, at least in the way that Elasticsearch works in the overall generative AI system. But for us, as long as we focus on helping our customers get relevant content out of the corpus of data inside of Elasticsearch, there are lots and lots of use cases, whether it's just displaying results on a website or feeding it into a generative AI system. In the end, ultimately, the best thing that we can do is put really good, powerful relevance tools in the hands of the users, some of which are fully wrapped up and simplified and easy to use and abstracted away. And some, as you know, are these core foundational tools that people can pick and choose and use and optimize in their own different ways. I think that's what we've done with ESRE. And I'm actually very happy with where the product is right now. There's still, of course, more to do with it, but we're really excited about it.
So you mentioned, this ability to bring your own data into this LLM experience. I understand that, I think, pretty easily. We all have our own databases for all of our own things. And, there's massive data silos in pretty much every company, a big company anyway. But if I'm bringing the Elastic ESRE stack into my organization, or I'm already using it for one of the other use cases, do I even need to use OpenAI or Llama or any of these other LLMs, or do I just use ESRE for my AI stack and I can create this conversational interface for my enterprise data, for example?
The short answer is that you could do all of it inside of Elasticsearch. you could sort of eliminate the need for the foundation model. The reason that, Llama and GPT and others are still so popular and so powerful is because they're really, really large models that have been trained on more data than anything. They've seen all the training data, and the models themselves are so large. They're not the sort of thing that you're going to put inside of an Elasticsearch cluster and run yourself. And so what we typically see, and the thing that we've at least been focused on most immediately, and I can talk about where I sort of see these things going in the future potentially, but the way that we see that people integrate this stuff now is to use, there's a technique called Retrieval Augmented Generation. It's pretty commonly known in the sort of generative AI space. But the idea is to say, hey, if we're going to ask ChatGPT to answer a question, or Bard or Llama or one of these, if we want to ask it a question, obviously they were trained on the public internet, more or less. They've been trained on this vast amount of human knowledge, but they don't know anything about, your internal company, vacation policy or something like that. And so the idea is that you would want to provide a copy of your internal company vacation policy at query time to the LLM. And you would say, hey, this employee is asking a question like, do we have these holidays off in the United States this year? By the way, here's a copy of our vacation policy. And so can you please answer the question in the context of this document that we're providing you at query time? And the way that you find that document is through a system like Elasticsearch. You find, the idea is that if we've indexed all of that content and we can say, all right, given this question, this is the most relevant document or the most relevant several documents for answering the question, we can help put that context into the prompt essentially of the LLM, and then the LLM can answer the question in that context. So it gets this sort of grounding in the factual information that's unique to your company, but it uses its sort of understanding of human language and reason that it learned from that, reading the vast majority of the internet. So it's kind of the bridge between what it learned on public data and what it didn't have access to when it was being trained, but that's being provided sort of at query time. And that's, at least today, probably the most effective way that we see these things being integrated together. But we will, I think, in the long term, see that these very capable models for answering questions, generative models for answering deep questions that require a lot of understanding, I think we'll see them shrink. We're already seeing the distillation of these models, and they're getting smaller and while still maintaining a lot of their capabilities. So, there could be a future because, as I said, you can bring a transformer model directly into Elasticsearch and run it on a machine learning node. And so there's a point in time where we'll be able to kind of provide that end-to-end experience entirely inside of one piece of software.
That's interesting. So the way I'm thinking about it, just to kind of recap what you said, is that I have all this internal corpus of data about my health plan and my vacation, all the internal policies and processes and kind of tribal knowledge, as people call it. And I can use Elasticsearch to index all those documents, all that copy, all that text, and then interact with it in a conversational way by you on the back end combining the results of the query that I typed in the form of a question, like, do I have any days off in the next 2 months? You're going to interpret that, get the right documents loaded for the context of the LLM, and then query it so it's conversational. Is that right? So how do you merge the results from, because just real quick, in case folks don't know, like a lot of this stuff is stored as vectors in a vector database, right? So let's take a little diversion down into that. Like when I first started learning about ChatGPT and then technologies like LangChain came out, I started building my own stuff, and 9 times out of 10, the examples on the web were using Pinecone. And I was like, oh, what is this Pinecone thing? Let me go learn a vector database. I'm like, well, Elastic has a vector database. Why can't I just use Elastic? What is the answer to that question? Like, can I just use Elastic for this with something like LangChain? And let's talk about that, and then we'll come back up to the surface and maybe answer the broader question.
The answer is you absolutely can. So Elasticsearch's vector database is highly capable. We built it directly into Lucene, which has some enormous advantages, as being the core relevance engine of Elasticsearch when it comes to things like filtering, which we touched on. Actually, we have a way of being able to do that. It's actually pretty unique because of the way we built our vector search algorithm. But we actually even go a step further than what the vast majority of vector databases do, including Pinecone. So like a typical vector database, at least today, they're again a point solution. You get your vectors somehow, and like the typical process that you're describing is you take plain text, the document that's in a PDF or on your wiki or something, and you pass it through a transformer model, and out comes an embedding or a dense vector, right? That's the output. And then that's what you store in your vector database. But most of the vector database vendors, they're just the storage engine for the vectors. They don't participate in helping you create them. So they expect you to either create those using third-party software or third-party API like OpenAI's. They have an embedding API. At Elasticsearch, you can just put a transformer model for doing embedding in the ingest pipeline. So you could say, when I send Elasticsearch plain text, pass it through this embedding model, and when the dense vector comes out the other end, store that in the vector database, but also store the plain text in our inverted index in the BM25 stuff. So we've pulled together a whole lot of that. And I think that the interesting part of what we're seeing, and I think you're seeing it emerge in the overall ecosystem, partially actually, I had the pleasure of meeting the folks over at LangChain who are great and they're doing really interesting work. We have an integration with them now as one of the retrieval backends for Elasticsearch. And part of that is because people are realizing that dense vector retrieval on its own, where you're just using vectors to do that retrieval rather than using the kind of more traditional like keyword or lexical matching, it doesn't work that well in many cases because most embedding models are trained on a domain of text. So it'll be trained on maybe pharmaceutical data, and it's really good at creating embeddings for any kind of data that comes in that's pharmaceutical data. Or maybe there's a different model that's really good at financial data because it learns those vocabularies and things like that. But if you use it to do retrieval on any data outside of that domain, it actually is like kind of nonsense. It doesn't work very well at all. It would work way, way worse than if you just put some keywords in there and hoped for the best. And so what we're finding is that in a lot of the academic research is coming out, the best performing models are a combination of the two. So you actually want both. And then there's a whole other category of things. Probably one of the more exciting things that we worked on or that we released as part of ESRE was a proprietary model that we built. It's an out-of-domain model that's meant to be used it's trained to work generically on any kind of text you throw at it. It doesn't have to be trained on a particular domain. It's a transformer model, but it's a different type of transformer model called a late interaction model. And it's really quite innovative. There are a couple of other ones out there that have been published, but Elastic has a really good one. And it's the kind of thing that we have to, if we're going to ship a model with Elasticsearch, obviously we wouldn't ship a model that only works on financial data because we have customers that use this for everything. So we had to aim at something that we could reliably feel like we were going to give our customers the ability to get retrieval, like high quality relevance out of anything they throw at this model. And so that was one of probably the third big pillar of the ESRE launch was the first release of our proprietary model, which is nicknamed ELSA. It's a Elastic's learned sparse encoder model. It's a really interesting thing.
So Matt, with that one, you're saying that if I have that, I don't need ChatGPT if I don't want to use it. I don't need OpenAI. I don't need Llama, and I can still have a pretty good experience.
Well, so this particular model is actually more a replacement for the embedding process for creating vectors, right? So
it's like the intermediary.
Yeah. So, when I was describing retrieval augmented generation, there's this process of like finding the most relevant document and then passing that over to the LLM with the original question. How you find that most relevant document is up to you. And it's, at least inside of Elasticsearch, you could use our BM25 algorithm, which has been around forever since the very first version. You can use dense vector retrieval using our vector search database and using a specific dense embedding model like we were talking about. But those have the downside of if they're not trained on the same data you're embedding, they can create embeddings that don't really work. Or you can use something like ELSA, which is something that's meant to be an out-of-domain retrieval model and still provides kind of what the promise of the reason everyone got so excited about vector databases and dense vector embeddings is because they can understand semantics better than keyword matching. And so it it kind of combines, it has the capabilities of understanding semantics, but it's not, it doesn't have to be trained on a specific kind of corpus or vocabulary of data in the same way. But in the end, those are all three ways of just finding the most relevant document or two to pass along to something like Llama or ChatGPT or whatever.
I just want to make sure I understand all the pieces in this modern AI architecture. So I have a corpus of data, whether that's my company's private corpus of data or that's the whole of the internet or whatever it is. So I have some data set. I pass that through a transformer. That transformer generates vectors. I store those vectors into a vector database. That is a LLM. All of those vectors that are stored in the database, is that what you would call the large language model?
So no, the vectors themselves are just representations of the original pieces of text. And then the large language model typically, so once you get everything stored as vectors, the next step for retrieval to say, okay, I stored all of my documents as vectors. I turned them into vectors. I've stored them in my vector database. And then a user comes in and types a question on your search box. And you do the same thing, that question. You pass it through the same transformer model. It creates a vector out of the question. And then the vector database's job is to say, okay, given this query vector, what are the 10 vectors that are most similar to it? And that would be equivalent to showing you the top 10 search results. You get those vectors back. Obviously, you reference back to what the original text was because no one wants to look at a vector. It's just a string of numbers. But that is the retrieval model for getting relevant content back. And then you would pass that into the large language model, or you pass maybe the top document into the large language model because there are limits to the amount of context you can send as part of the question. And it's probably part of the nuance of all of this stuff is that actually the transformer that creates the embedding, that's actually also a large language model. In true terms, it's been trained on a lot of language, and its output just happens to be an embedding rather than a bunch of sentences, which is what the output of a model like GPT is. The difference, or at least the terminology that I think people are kind of standardizing around, is like large language model have been around for a long time. You can use them for a lot of different types of things. They're of very, varying sizes. GPT-3, GPT-4, Bard, Llama, those are really foundation models. Those are these models with billions of parameters where you could have an embedding model that doesn't have anywhere near that number of parameters. It's, 4 gigabytes or 8 gigabytes of RAM to run the thing as opposed to several terabytes of RAM. So while they're all large language models in the end, in a technical sense, ultimately the output ones, the ones that you're using to like generate a really long prescriptive answer typically, is what I would call a foundation model. And that's where the kind of people are talking about who's going to be building foundation models in the future. Is it only going to be the largest companies out there, or are startups going to be able to catch up? How much money will they be able to spend?
Because it requires so much GPU time to do it.
Exactly. Yeah. And it's really the training, right? The training part is where the GPUs are so important. Once you've got everything trained, executing these models, sometimes for some of the really large ones, obviously you want to execute on GPU, but you can execute, typical like embedding transformer model on CPUs very ably. Maybe the thing that's coming out possibly here in this part of the conversation is something that I think is really fascinating about this space right now, which is that it's evolving very quickly. It is technically fairly detailed and fairly nuanced. It's unique in the fact that it has also sort of captured the consumer mindset very rapidly. And so you have this area where it's a bunch of nuanced technologies. They fit together in ways that are not immediately obvious. Everyone's using them in some way or another. At least they're interacting with them. Both of my parents have used them. My niece and nephew use them. You hear about them constantly. And that's it's an interesting thing when such a new and kind of nuanced technology comes out, and then you find yourself at a company that has a place, like a really nice, important place to play a role in that overall ecosystem, like Elastic does, in being that retrieval model that can provide context at the time, which is fortunate. But it's definitely interesting, especially because so much interest is being generated by the fact that it is such an accessible technology, and consumers have just latched onto it in a way that we haven't really seen before, or at least I have not seen a technology take over quite in the same way in the recent past.
No, the most rapidly adopted technology of all time, right? It was like 100 million users after a few months or something.
Well, I think that also means every site, everything about it is accelerated, right? Like I got to the trough of disillusionment faster with ChatGPT than I've ever gotten to that before with any other tech.
But now you're past that and using it.
Well, I'm starting to figure out where it fits into my life, right? Like you watch all these companies try to move quickly and what they end up creating is really shitty user experiences, right? Like I'll call out HubSpot, for example. I love HubSpot as a technology. I love an underdog, but their implementation of ChatGPT is really bad. And they're trying, and even the CEOs out there, like commenting on it, but it's a toy. And so I can't use it to do any real work. And part of the reason is because it just doesn't do exactly what I want it to do. Knowing what ChatGPT can do and then trying to come into HubSpot and say, do this thing for me, and it just totally fails, means, I'm going to lose trust quickly. And then stuff that it can do, it's not always the same result. So Matt, like with all these embeddings and using vectors and, kind of like how you get the search results back over time, we mentioned earlier, relevancy is kind of this journey that is never ending. How do you make these things more predictable so that when I ask the question, do I have any days off in the next 2 months, I get the same answer no matter who I am, where I am, what language I'm asking in, et cetera?
I mean, I think one of the big advantages of using retrieval augmented generation is that it does provide a grounding for the answer, right? So if you ask one of these foundation models just a question, and then you ask it essentially the same question a day later, there's randomness in the model, right? So you're going to get slightly different answers. And you can imagine all the reasons why. Like if I ask it, like, what's the 401k policy for my company? It's probably going to give an answer, actually. It's just who knows which company's 401k policy the answer is going to be about. And on day one, it may be different from day two. The retrieval augmentation, providing that context at query time, provides a grounding for the answer. So the model can really read the detail at the same time it's interpreting the question. It's interpreting what it's reading in the context. And so you do give it more, essentially it's more of a control over what the output is going to be. And I'm not saying that it eliminates hallucinations and things like that. I think that's still an open problem, but it does minimize what the kinds of hallucinations that I think people have started to see in ChatGPT, because it's very grounded, right? It is grounded in, a relatively small amount of context that it's trying to interpret and then provide you an answer for. And I think that that's important, right? Especially inside the enterprise. And to your point about HubSpot, I think that a lot of companies, I love the fact that they're just going for it. As with any company, I hope everybody is able to do these things, but I think everyone is also still figuring out what the right applications of this technology are. And I won't be surprised if just chatting back and forth with a foundation model isn't ultimately the way that this stuff really succeeds in our lives and inside enterprises. Although I think there will be a place for it, but I think we're still just at the beginning of figuring out where it will really, really work. And we may be very surprised at what it ends up doing.
Sorry, I just have one more clarification. I just want to make sure I understand it. So,
Chad, this is not a training course.
I know, but I want to make sure I understand it. I think other people want to understand it too.
Just kidding.
So there's an embedding transformer. Elastic provides one of those. That creates a bunch of vectors. It goes into a vector database, which Elastic also is. And there's a bunch of other vector databases in this market too, Pinecone and Vectara and other things, right? So you're sort of competing against them, but you have the added benefit of all of the search relevance that they don't because of Elastic's history. Then when I ask a question, that goes through the transformer again. It pulls up a vector from the vector database, and I push that through GPT-4 to get my actual answer generated, or Elastic is generating the answers now too, or what is that final piece?
Yeah, so the final piece is that once you get that set of vectors back, or the most relevant vectors back, you reference the original text that vector represents, right? Because you want to ultimately, what you want to present to the foundation model is at the end, you want to present, hey, this is the natural language question that the user typed in, and this is the context in which we would like you to answer it, or we'd like you to use this context to answer that question. So that also needs to be natural language. But yeah, that is kind of the last point. And in many cases, that last stage, we're pushing all of that text to something like OpenAI or Bard or one of the other foundation models. We don't do that behind the hood. That's something that at least in the case of Elastic, our users use us for all the retrieval, and then they plug it into OpenAI's API. We do have a little connector that will connect on your behalf, but it uses your API key. We don't try to hide the fact that you're ultimately going to be, if you choose to, you would be sending that data over to Azure's OpenAI service or the OpenAI API directly. That is typically the very last stage. But what I was saying, which may have been the confusing part, is that over time, that very last stage can potentially be solved by not just Bard or Llama or ChatGPT. It could be solved by other LLMs that have been distilled and kind of shrunk in a way that you could actually potentially pull that.
Those are the domain-specific ones you were talking about.
Well, they could be domain specific, or they could just be very, tuned for specific kinds of question answering, but they don't have to be. I don't know anything that isn't public about GPT, those models, but I think GPT-3 was something like a 780 gigabyte model when it was finally fully trained. So that's 780 gigabytes of RAM that you need just to load the model, and not to mention the computing power to do inference on it and how quickly you can do that to actually start producing an answer. That's something that you won't running on specialized hardware somewhere in a data center, probably not running inside of your Elasticsearch cluster. But if you could imagine something that is capable like a GPT style model that is tuned for question answering, but is 32 gigabytes of RAM as opposed to 780 gigabytes, then that's something that it's more reasonable that you might run locally inside of your own data center or inside your own infrastructure. And what we're seeing with open source models, which I, of course, maybe my background just indicates this, I believe in open source. I think that open source will have a bright future in this area, just like it has everywhere else. We may see open source models really do some incredible things. So I wanted, part of the strategy that we've had at Elastic is, as we think about this, how we fit into this ecosystem, is to maintain an open viewpoint on where customers put the LLMs and which LLMs they want to choose. And we want to make it so that you can bring an open source LLM that Elastic has nothing to do with, that is something or something that you've trained yourself even. And I think that having that kind of open perspective will serve us well, because it's hard to predict where where the ultimate value is going to be created. I think there's a good bet that a lot of the best work will ultimately end up in the open source domain. That tends to be one of the trends. Now, I'm sure there are a lot of people who would disagree with that, but I do think that there's even if that's not true, I think because we are mostly unopinionated about it, we can, you can still integrate with OpenAI if you'd like to, or you can integrate with, Bard or whatever other, of the foundation models are run by the really largest companies out there.
I think it gives companies like pharma companies this opportunity to create software that's specific to the pharma space. And, it's an LLM that's very specialized that they sell to other pharma companies that may or may not make it into open source because there's too much money to be made without it being open source. Yeah.
So to Steve's sort of earlier point about the fact that some people's implementations of these things, like whatever, he doesn't like HubSpot's implementation, feels like a toy. How, if you're building a vector database, well, Elastic is building a vector database or has built a vector database, and it competes against these other vector databases. How do you think about trying to figure out the comparisons between these products and which one is the right one? Is it the case that you're trying to build something that Elastic's relevance engine is the best in all cases, or is it like, well, this one will be better for these types of things and those will be better for those types of things?
Yeah, so I think our goal is to build the best retrieval engine in the world. So that includes the vector database. So we don't see a part of the vector database market that we want to seed elsewhere. And I think that the way we've approached it with the implementation we have today and the things that we'll continue to invest in there, we're in a very good place to be very competitive. So yeah, there isn't a part of this that we want to avoid. And I think that really our viewpoint is that vector databases are extremely important. We actually started building our implementation probably about 18 months ago. So before this stuff became really one of the more popular things, it was already evident that vector databases were going to become more and more important over time. So we started building our implementation back then. So we want to make sure that if you use this as a pure vector database, like something like Pinecone or Vectara or some of the others that are Quadrant, the others that are out there, we want to compete head to head and have every bit as good of an implementation as any of those companies out there. And we participate in all the public benchmarking, the ANN benchmark data sets that companies opt into. Not all of our competitors choose to participate in those benchmarks, but we do. We're an open source company, so we do that. And so we can see where we fit in terms of performance in various data sizes and data sets and different, performance characteristics and things like that. But the view really is that, so even outside of just looking at making sure that we're really very good at doing vector database search or vector retrieval, I think it's very clear to me, and it's becoming more and more clear in the broader community around this, that vector search is not enough for doing all of the things that you want to do in these generative AI systems. So your stack is going to need a lot of other things, like creating the embeddings themselves, and using transformer models for other parts of the retrieval system. We haven't really talked about this because it hasn't been as relevant, but there's oftentimes you use transformer models in re-ranking. So once you've retrieved a bunch of documents out of after your search engine, you can push them through another model that's specifically trained to rank documents against each other given a question. And those are also transformer models. And so more the point I'm making is that Elasticsearch, I think, has hit a much broader set of the tools that are needed to build real enterprise grade production applications in this space. And that's going to also maintain, our focus as well. So we will hit the vector database market, and we've made, I think, a really strong investment there. But we're going to continue to also make sure that we're building the full suite of tools that are needed to take that vector database, pair it with all the other things that need to happen if you want to build this thing into real production applications. And maybe the best example is, enforcing things like document level permissions. So, when you have an internal company wiki and you're in your role and I'm in my role, we have different levels of access to different kinds of content, right?
Yeah, different files on Google Drive. Yeah,
exactly. And so if you're using a vector database that's a pure vector database and all these documents have just been turned into vectors and then you spit out the relevant ones, you might provide context to the foundation model that includes a document that I don't actually have access to, right? That I don't have permission to. So the answer could, contain information that I shouldn't be able to see. The enforcement of things like document level permissions is an area where Elasticsearch shines. That's something that we've been doing forever because we're an enterprise grade search engine. We've been doing that kind of thing since the very beginning. And you have to be able to couple that with something like a vector database. So a vector database retrieval coupled with enforcement of document level permissions. These are the kinds of things that, as we talk to our customers, as they're starting to plan out how they build these things, that's really where kind of the rubber meets the road is, can we still do those things while using all these cool new technologies, which is where I think we really have a leg up, at least in this particular space.
So if I want to build an internal system in my enterprise that allows people to generate content that speaks in the language of how other content has been generated by my enterprise, right? It's brand appropriate. It uses our voice, all of that, right? I still need this, like you said, I still need this last piece. Whatever I put through Elastic, I still got to push it through like OpenAI's API or something like that. How do I do that in a way which doesn't end up generating an answer that was based on a document that I wasn't supposed to see in the first place? Like, do I need a separate LLM model that's per user still somehow that was trained on the data that each user could personally see?
So you shouldn't have to, because we're at no point in time, this is actually one of the reasons that fine tuning is one of maybe I could have said earlier on, primarily two ways that you bridge private company data with the public LLMs. One is this retrieval augmented generation that I've been talking about. The other is to do fine tuning, where you provide your own documents and you retrain the model a bit. It tends to be pretty expensive, but that's actually a scenario in which if you're fine tuning, you would probably have to fine tune on a per user basis, because you would have to fine tune the model on just the documents that Matt is able to see inside of the Google Drive and inside of the wiki. And then we would have to do another one for you and another one for Steve. And that becomes very difficult. But if your retrieval model enforces all of these permissions, and you're only providing context that to the LLM that includes documents that I have the permission to see, then it won't answer it won't give an answer outside the lines or using content that I didn't have permission to access. That's one of the other reasons that people, I think, have leaned so heavily into retrieval augmented generation, and why I think that there's probably a long future for it. Even as fine tuning gets easier, it has a lot of sort of inherent advantages to some of the other approaches there.
So is this something that you guys, I mean, maybe you can answer this, maybe you can't, I don't know. But are you actually building like a private chat GPT to query a company's own data?
Yeah, I can't really talk about the things that we are building. I mean, we showed the demo that Steve referred to earlier that Ash and I published on YouTube was kind of an example of that, where we were using the final stage of it was the Azure OpenAI service. Right. So we had an instance of GPT-3 running on Azure OpenAI that we were interacting with via API calls, but all of the content was indexed in Elasticsearch. And so as we go through that demo, you see we show some of these capabilities, like being able to enforce document level permissions or personalize an answer based on where the querying user is located. If, as Elastic, is distributed all over the world. If an employee is asking a question about tax elections, it should be specific to the tax elections in Canada if they're in Vancouver versus if they're in California. So we did a lot of that stuff. But to be really honest, and I think it's fine for me to say this, we absolutely view the search space at Elastic as fundamentally a developer tool. We have 3 different product lines. We have observability and security in addition to search. And this may be something that's a little different from when you were at Elastic, Steve, but I think that ultimately search ends up being a developer tool first and foremost, and probably always will be because of things like how it gets integrated into other software. Whether or not we were building like an official version of that demo that we showed on YouTube, ultimately in the end, I think we really firmly believe that the right thing for Elastic and for customers and what people will ultimately latch onto and build really valuable things from are these fundamental tools, these fundamental capabilities that we put into APIs and make easy to use as developers. And they can build their own chat interfaces if they want to, or something that we have not invented. And that's kind of the beauty of why Elastic has been so successful, is because starting with those like very core capabilities, then people go off and build, a huge variety of things like, the APM tool that we built. I watched Rasmus's interview, right? And things like that. So I think that we will continue to focus on making sure that we're building these foundational capabilities, and that's a good bet.
Where's all this going? You talked about, domain specific models, which I think is like totally accurate and is what's happening right now. People talk about artificial general intelligence, the mastermind that you can just ask any question that has all the answers that don't just equal 42. And then you have all the stuff that's happening with regulations right now and all these companies reacting to the use of their data in these LLMs, like, Reddit having this kind of existential crisis right now. Like, where do you think all this is going in the next, not just like 2 years, but like 5-10 years, if we can look that far forward and be okay with being wrong when we look back at this podcast?
Yeah, and I certainly will be, but I think that I'm a believer that we're at an inflection point where we're about to see a lot of things happen that we probably previously did not believe to be possible. So I think that we're probably closer to things like however people are going to define AGI, and I'm sure the goalposts will move. I think that we're seeing things already that are pretty compelling in that area. I think there's a lot of question around, AI safety that I think is important. There will be a question about regulation that is ongoing that will be probably fascinating, and I'm not really qualified to have much an opinion on. I do think that as companies, or the things that I think a lot about, as companies really start to want to put these things into production, they're going to be thinking a lot about alignment and how they can make sure that the outputs are safe or somewhat predictable, and safety in terms of like, removing types of bias or making sure that they don't output things that are, violent or, bad in some way by some definition. But I also think that companies are going to be ultimately continue to be concerned about their data privacy, which is something that has, it seems kind of like old news now, but if you think back in like 2011, 2012, that wasn't the first question that we were getting about our SaaS service is, well, okay, if we were giving you this data for the search engine, where are your servers and where are things being transmitted? But with things like GDPR and then all of the regulations that happen in Europe around, even just tracking internet activity and things like that, this has become a much larger part of every company's compliance responsibilities. So I think that's going to be a big part of the discussion as these things go into production and people start using them and helping their own customers leverage them. They'll be thinking about that quite a lot. The exciting part of the answer is only that I believe we're still just at the beginning of seeing really interesting new capabilities in this space. I don't know what exactly they're going to be, but I am a believer in the rapid progress that we're making. And then certainly there's a lot of unanswered questions as this applies to enterprise software and companies wanting to build them and leverage them themselves. That's where I spend most of my day thinking and worrying and planning. But yeah, where do you think it's going to go? I mean, what do you
pulling
predict?
up my notes? Sorry, you guys could see my phone. We actually talked a little bit about this. Like, one of the places I can see it going is this idea of having all these specialized models. When I think about AI, I think about trying to replicate us, right? Like humans. And so when you have all these domain specific models, that's like having 20 PhDs in a specific topic for an AI, because they can access all this information. They can do it very quickly, and hopefully it's conversational and you can comprehend what it's saying when you're interacting with it. And if that's the case, then we can take Einstein and all these other super smart scientific minds and kind of encapsulate all of their knowledge in these LLMs and then have the specializations cross over to create new things. And I think that's where the interesting stuff will really start to happen, is when you take specialized models and they start interacting with each other. And that's what scares me about AGI, is like the combination of the smartest people in the world on a topic to date combined with the smartest people in the world on another topic to date, and them getting together and basically coming up with new stuff. And I think that's where all the really interesting new things we've never thought were possible before will start to happen. Like maybe the secret to flying cars, which I've been promised my entire life, is somewhere in the combination of all the knowledge in science and physics and energy and something else. You know what I mean? And maybe there's just two people have never met. But by having all that knowledge eventually encapsulated in these models, maybe those two pieces of information can meet in some way that creates something new.
It's a fascinating viewpoint. I like it. I think that there's definitely something to that.
There's got to be something there.
Like a podcast with all the smartest people that ever lived simultaneously talking to each other.
Well, just imagine if they could have those conversations basically at warp speed too. It's not like you have to go to a conference and have a 2-hour long hallway conversation between these two brilliant people. They could just have that conversation instantly. These are, the implications of that are pretty wild. The number of people you could potentially meet if you have a well-trained agent for yourself and the things that you do and the things that you could potentially have conversations with hundreds of thousands of people through an agent of yours, essentially a software agent somehow, and their software agents, and meet people who have common interests and meet people who understand things that you don't, right?
That's like the Black Mirror, a couple of Black Mirror episodes, I think, have delved into that idea of like Twitter at AI scale and speed.
I've not seen Black Mirror. I feel like I hear enough references of it that I need to get in there and I need to watch it.
Yeah, one of the best TV shows ever made.
Yeah, I think you would love it. The last season that they just did was more like, it was like horror movies or horror series or something rather than like technology. But usually they take a piece of technology and they take it just far enough into the future where you can actually envision that thing happening. And then they play out a scene or, a story that's influenced by that technology being as advanced as it is.
Yeah, how it affects humanity. I think one last question here in terms of AI and generative AI and all the stuff we've been talking about. Do you think that the government has a role to play in regulating this, or do you think it should be really mostly hands off and just kind of let companies figure it out?
Chad wants to know if Elastic's hiring a lobbyist, and if so, here's his resume. No, I'm just kidding.
I go back and forth because I'm not afraid of a super general intelligence taking over the world. And I know some people are and a lot of other smart people are not. And I just don't think we need to worry about that problem personally. But I'm curious on your thoughts.
Well, I think that there are a lot of ways to look at regulation and calls for regulation in particular, and some may be pessimistic, some optimistic. I think the downside to too much regulation would obviously be that it can stifle the kind of innovation that we're probably just at the beginning of seeing, because the more regulated things get, the harder it is for small companies to operate, right? Because they don't have as much machinery to do the things that are required to comply.
And other countries won't impose the same regulation, so we'll just fall behind.
Right. And I think that is very possible. And, and this comes to, this can hit you in a variety of ways, right? A lot of software engineers are using things like Copilot now inside their IDE. And there are questions about using Copilot because what is the license on the output of that, because it was trained on open source code. But I do think, for me at least, and maybe because of my background and my belief that startups are such an agent of creating innovation, I hope that we don't regulate to the point where it's so difficult for startups to operate and build the things that we haven't thought of yet. But I do think there's probably a role for regulation in general. The governments will work on these things.
They will. I'm just, what's an example of a good AI regulation that you think a government should pass?
Oh, I don't know. I'd probably have to think about that. How about you? What do you think?
I can't think of one. I'm not a hardcore libertarian by any sense, but in this case, I haven't seen AI be dangerous yet. Generally regulations are passed because something's been done which has already been shown to be dangerous. People drive, cars were invented, then we had to add seatbelts when people died or whatever, right? Airplanes crash, then we had to add some regulations. Usually regulations come after something bad has happened, and I haven't seen anything bad happen, so any regulation feels premature.
Yeah, and I think that's probably true, at least right now. Like your analogy with the seatbelts, that's probably analogous to like the alignment problems that people talk about around, helping outputs of these AIs be, not telling you, nefarious things or whatever the proper word for it would be. But I think that the question, at least immediately, is how to do that alignment properly. I don't think we even necessarily fully understand all the mechanisms that make the AIs work yet. And then so alignment and regulating alignment is going to be a very difficult thing until we really truly understand all of that. And then at some point in time, there probably will become a better understood mechanism, and there may be regulation in those areas.
But why shouldn't we be able to have an LLM that tells me how to do nefarious things, or that generates, adult content that I'm sure people will want? And I can understand why, a big company like Microsoft or Google, they don't want it because they don't want the liability of saying, oh, look, Microsoft told me how to build a bomb or whatever. Fine, they can take it out. But I don't think there should be a law like preventing any dissemination of information. So if someone else wants to build an LLM that tells you how to build a bomb, like they should be able to do that, I feel like.
I wonder if it'll be something deeper, like a different aspect of the regulation as opposed to, regulating the output itself. You're regulating the...
Matt, isn't that how it usually goes? It's always the regulating the output. Like, we have nuclear power, but we don't have nuclear explosions going off every day. You know what I mean? Like, you can regulate the output. We have cars that are capable of going 150 miles an hour, but we regulate the speed. And so I think that's more of where we should focus with these regulations, and I hope that's where we'll eventually end up, because that's kind of the template that we've been using, is regulate the output. So like for deepfakes, for example, you say nothing's bad has happened yet with AI. That's not true. It's just a matter of levels and scale. So like there was a woman in Phoenix that got a phone call from an AI version of her daughter claiming she had been kidnapped and asking for ransom money. That's bad.
But that's already illegal. Like, you don't need another law. That's already against the law.
I know, but what I'm saying is, like, when you say not bad stuff hasn't happened yet, it's just levels and scale. There will be eventually something that happens that's bad enough that causes the government to move on something. And what I think a lot of people are worried about is that we'll do that prematurely and lock out some innovation. Like with deepfakes, we could say deepfakes are illegal. I don't think we should say that, because deepfakes can make movie production and game production much faster.
Yep.
And so we'll get better content. And I like movies and games, and I want those things. So
or even webinars that were generated.
Yeah, or webinars or stuff like that. Like
we'll get personalized movies, right?
Yeah.
A movie just for me, right?
Yeah, my own Black Mirror episode.
Oh, wouldn't that be crazy? Like you pick the actors, so they go make the movie, but they do it in green screen with like green. Oh, that's a business idea.
Or the whole thing is just CGI with deepfake actors that you chose.
Yeah, but it's choose your own adventure, but with actors and AI.
And they write the story, but they put it in a setting that you like, and it's a whole like
Well, we'll be making Tom Cruise movies for the next 1,000 years, right?
It's very possible. I think there are some like very compelling, and these are admittedly even just like very small ideas, but there's some very compelling startup ideas just in this particular area. Like seeing the ability to replicate someone's voice, we've seen some of that in the deepfakes, right? Where you can deepfake somebody saying something that they never said by just training on, an hour's worth of their spoken audio, like they could pull out of a video like this. You could see that being used for really bad things. You could also see it being used for like really kind of great, incredible things, like being able to recreate, memories of family members, right, who have passed away or something like that. I think that would be, who knows where those things are going. And I don't know where the regulations should be, but I do hope that we don't start regulating so quickly that startups and other companies don't have the opportunity to come up with these applications that we haven't thought of yet and that are probably just now emerging and will be. We're at the beginning of it, I think.
All right. Hey, everybody. Thanks for listening. Matt, that was awesome. I learned a lot. I hope other people who are listening learned a lot. And I think this is not going to be our last episode talking about the AI space and generative AI. And maybe we'll have Matt back on next year and we'll see where things have gone from now till then.
Well, thanks for having me. It was great.
That was awesome. Thanks, Matt. All right. Thanks, everybody, for listening. Share this episode out if you can. And we'll see you on the next episode. Bye-bye.